Of course, that's fiction. But did you know we've already sent 3 scientists, 2 geologists and a biologist, to Mars? Their names are Spirit, Opportunity, and Curiosity. And they're our intrepid roving investigators.
You know, I have one of the greatest jobs in the solar system. You know, I get to lead a team that drives a rover on the surface of Mars.
Getting there was hell on wheels. And there've been some bumps in the road. But these robot scientists are seeing, touching, tasting, drilling, and analyzing the surface of a planet where we humans cannot yet go, outliving their expiration dates by months, then years, putting up with endless requests from their Earthlings, sending home vital information about the waters that flowed on ancient Mars and everything else needed for life.
There are places on Mars that at one time were habitable, so we're poised to go look for signs of ancient life.
And now there's a new super rover in the works that will try to figure out if human scientists can follow in the bot's never-say-die footsteps and make a home on the red planet. These are the stories of a lonely blue marble, sending its intrepid little machines to places no human can yet go, to the far ends of the solar system and beyond. This is surely the cutest family tree in the history of space travel. It's all of NASA's Mars rovers, generations of robot gumption, stretching back to 1997, when little Sojourner made her debut on the surface of the red planet. Her larger descendants, the twins, Spirit and Opportunity, blew the minds of their controllers. And Opportunity is still at it. And the youngest, biggest beast is Curiosity, now starting its 5th year of groundbreaking research and exploration. Sojourner hitched a ride with the Mars Pathfinder mission. After landing, Pathfinder opened its petals, and beagle-sized Sojourner started out on a planned 7-day jaunt, exploring the Martian terrain. She spent 83 days wheeling around, snapping pictures, and chemically tasting the terrain and the atmosphere.
Pathfinder really showed us how important it was to have mobility on the surface of a planet so that you can see the most interesting thing, you can go over and sample it. If you're fixed in place, you're limited as to what you can reach. So mobility is key.
What Sojourner found was that Mars had volcanic rock very much like the Earth's, suggesting what scientists suspected, that the red planet had gone through an evolution very much like our own planets, long in the past. In 2003, the same year Sojourner was inducted into the Robot Hall of Fame, the next generation of rovers, twins, Spirit and Opportunity, blasted off from the Kennedy Space Center about a month apart, each powered by a Delta II rocket. It wasn't an easy trip. The sun went ballistic a few months in, bombarding the rovers with brutal radiation. NASA's $850 million babies weren't communicating. It was a nail-biting moment until they tried the old IT help desk standby. Have you tried turning your rover off and back on again? And it worked. After a 7-month trip, the first of the twins, Spirit, was hurtling toward Mars at 16,000 miles per hour, about 10 times the speed of a bullet. The heat shield in the front of the rover vehicle got about as hot as the surface of the sun. A supersonic parachute deployed.
Atmospheric entry.
It was time for the Earthling controllers to strap themselves in. It was going to be a bumpy ride.
Current altitude 8,000 feet.
The heat shield jettisoned. The The airbags blew up in less than 1,000th of a second. And then she bounced and bounced. 28 times.
You know, kind of unusual when you think that there's this $400 million rover inside and it's bouncing around on the surface and eventually comes to a rest. But it worked very well.
Finally, the airbags deflated and the solar arrays opened up, charging the power-hungry little rover. And she lifted her head, the panoramic camera, and sent her first beautiful "We Are Here" postcard. Then Spirit looked homeward, snapping the first ever picture of Earth taken from the surface of another planet. Her Earthlings went crazy with joy. But then, disappointment. They had landed Spirit in a crater that they had hoped was once a lake. But what they found there was not a lick of evidence of water.
And when we landed, we found nothing but volcanic material, basaltic rocks. And so Mars had thrown us a curveball.
3 weeks later, twin Opportunity made its own bouncing baby rover arrival on the opposite side of Mars.
At this point in time, it should be on ground.
The Mars Exploration Rovers team were hardly the only ones to get attached to their robotic critters. These charismatic machines elicited enormous affection among the public, partly because they were outright cute. They could have been designed by Pixar.
Well, the rovers are adorable. I mean, they're cute, they're courageous, they're exploring on our behalf. And so it's hard not to become enamored with them and affectionate with them and regard them as adorable.
Golf cart-sized Spirit and Opportunity were designed to be wandering geologists. Instead of picks and hammers, though, they have little particle blasters that they can use to take samples, and spectrometers and microscopes to examine them. Their holy grail? Evidence of liquid water. Spirit got off to a rocky start. She drove off on her first assignment to investigate a rock called Adirondack, stretched out her arm to touch it, and froze. Her memory full. With bated breath, her humans commanded her to erase her memory, a terrifying reboot. But it worked. Poor Spirit got a reputation for being the bad sister, or at least the unlucky one.
You know, nothing went right for her. She landed first, she landed in these volcanic material. We were hoping to find lake red sediments.
But Spirit made up in spirit what she lacked in luck. In December of 2007, one of her wheels broke. Her controllers resigned themselves to the extra drag.
We drove it mostly backwards, dragging that right front wheel, but it was like a ball and chain. But that actually turned out to be one of the biggest scientific boons of either rover, because it would scrape the surface material and reveal what's just underneath, stuff that we normally would just drive over because it was obscure to us. And that's where Spirit made its biggest discovery.
What Spirit had found was a kind of rock called opaline silica. This can only form in the presence of both water and heat. Spirit's twin didn't need a ball and chain to make fantastic discoveries.
Opportunity lands right from the get-go, discovery of water-formed rocks, right? You know, it came easy.
Opportunity landed on a flat plain known as Meridiani Planum. Here, she found little so-called blueberries that contained hematite, an iron ore which is almost always associated with water. It looked as though Opportunity's landing site was once the shoreline of a salty sea, but one that was too salty and acidic for life as we know it. After thoroughly investigating its landing site, Eagle Crater, Opportunity traveled to Endurance Crater, and again found evidence of ancient water. But it too seemed too salty. Finally, at Victoria Crater, almost 4 miles from the landing site, she found her Holy Grail.
Where Opportunity is today is we see evidence of neutral pH water, water you could drink. I mean, ancient water. We're talking 3.5 to 4 billion years ago. So this is very exciting because these are the conditions we think are most hospitable to the origin of life, at least as we understand it. We've certainly established that the habitable conditions, the physical conditions, the liquid water, the right temperatures, sources of energy, and now neutral pH water all existed at that time, at a time when life started on Earth.
Both Spirit and Opportunity did more than find evidence of ancient water. They photographed Earth-like clouds in the Martian sky, found the first meteorite ever discovered on another planet, and proved what scientists long suspected. The place was riddled with dust devils. Dust devils that, instead of choking our roving ladies, kept them going, long past their sell-by dates.
Well, the rovers are solar powered, and dust accumulates at the rate of about 1% a day, which means that, after 100 days, most of the solar rays would be covered by dust. And so that would mean we'd have, a 100-day mission, a 90-day mission. That's what we designed. What we didn't expect is that wind gusts or wind events or dust devils or something would come along and blow the dust off the arrays. I mean, it's like someone came by with a leaf blower and just dusted the whole rover off, and it was factory new again.
But dust was not always their friend. Spirit and Opportunity had to hunker down for 2 months while dust storms raged, limiting the solar power to a level that nearly caused the permanent failure of both rovers.
So they went radio silent, radio dark for days. And so we didn't know if the rovers were dead or alive, and we programmed the rovers to wake up at a certain time in the future. And it was very dramatic because all of us were there in the control room waiting for the data to come down. Would we hear from Spirit? Would we hear from Opportunity at the expected moment? And we'd gone days without hearing from them, and we'd seen orbital imagery of the planet just clouded in dust. Would they be alive? Would they tell us? And sure enough, right at the moment they woke up, they said, "I'm here and I'm okay."
In 2009, after 5 mission extensions, Little Spirit would get stuck in soft sand, but continued sending data. She stopped communicating with Earth in 2010 and was declared dead a year later. She had explored and phoned home her results for more than 5 years, traveling almost 5 miles.
We had worked with Spirit from the beginning, and now Spirit is missing. We can't help her. She's on her own, and then we never hear from her again. And we tried to look for over a year. We listened with the Deep Space Network every day. We sent over 1,400 commands to elicit a response, and we heard nothing. We tried. And so we don't know what the last moments were like. It's very much like a loved one missing in action, because you don't know whether they're dead or alive, and you don't have that sense of closure.
People forget, or perhaps just can't believe, that Opportunity, the lucky sister, is still going strong. After more than 12 years, 27 miles and 10 mission extensions. Considering she was expected to go 600 meters, that's quite a scientific bonus. And set the rover bar awfully high.
They both outlasted their planned lifetimes by years, and one's still running. So his engineering accomplishments, they're pretty stunning. Curiosity has to live a long time in order to beat Opportunity.
Curiosity, of course, is NASA's next generation rover, lovingly crafted over many years.
All right, stand by for test.
You have to wonder what Opportunity might have thought of NASA's crazy scheme to land Sojourner's granddaughter, the biochemist of the family. On August 5th, 2015, Curiosity's vehicle burst into the atmosphere at 14,500 miles per hour. And, like her predecessor, deployed a supersonic parachute and jettisoned the heat shield. But instead of bouncing this baby to its landing point, they cut the cables, fired up some engines, hovered, and used a sky crane maneuver. To ever so gently drop the rover to the ground and cut the umbilical cord.
UTIP is good. Touchdown confirmed.
Curiosity was born ready to roll, rather than being dispatched from a lander.
Opportunity is the field geologist for Mars. Curiosity is the analytic chemist for Mars.
So we say, okay, well, there used to be water a long time ago on Mars, but you need more than that to support life. And so Curiosity came along to look for evidence of habitability, which is all of the other conditions that you need for life. So water, you need the building blocks of life, you need those, you look for certain elements, and then also energy, something for the life to eat, sort of drive the metabolic processes of life.
Curiosity has a more sci-fi approach to her mission than her predecessors. Instead of touching and chemically sniffing rocks, she fires her laser and X-rays at them.
ChemCam on Curiosity shoots a laser at a rock that's about 7 meters away, and there's material that's burned off of the surface, and there's light that's given off, there's a spark. And then SuperCam has a detector that looks at the wavelengths of that light to figure out what are the elements that are present. And this is called laser-induced breakdown spectroscopy, but it's basically zapping rocks with a laser beam. So we have two instruments inside Curiosity that do geochemistry measurements on powdered rocks that the rover collects. And it's looking at the minerals that are in the powdered rocks.
The rover got her bearings where she landed, in Gale Crater, where it had looked from space as though there had been water once, and got down to business. Curiosity set off for a 3-mile-high mound called Mount Sharp in the middle of the Gale Crater at her top clip of 5 centimeters per second, a little over 1/10 of a mile per hour. Her long journey over a plateau brought her to an intimidating active dune field. Discretion being the better part of her honor, she took a hard right to skirt the dunes before heading up Mount Sharp. Along the way, she found formations that seemed almost certainly to have been the result of groundwater. As Curiosity continues her climb of Mount Sharp, she'll encounter younger and younger layers of soil, unfolding the history of the planet the way paleontologists and geologists do here on Earth. On the 4th anniversary of her landing, long after her official mission end of 2 years, Curiosity's controllers found a way to use vibrating parts of the rover so that she could sing happy birthday to herself. Which sounds a little lonely. They also gave the rover another 2-year extension on her mission. And a much more exciting present for a young rover: the ability to think for herself, using artificial intelligence. Curiosity can now choose which rocks she wants to study, and when to use her laser. So the next rover better be nice to her, if she's still alive and kicking in another few years. Despite all the wear and tear, all of her scientific experiments are still in working order. The wheels are getting a little dilapidated, but the holes have actually been found to provide some traction on soft surfaces. In her 4 years, Curiosity has returned more than 125,000 images, fired her laser almost 400,000 times, and driven 8.5 miles. She's done everything her Earthlings asked of her, and far more.
Curiosity has been exploring Gale Crater and Mount Sharp in Gale Crater to look for all of these pieces that are part of the story of habitability. And Curiosity's found all of them. So now we know that there are places on Mars that at one time were habitable. So we're poised to ask the next question, which is really to go look for signs of ancient life on Mars. And that's what we're doing with the Mars 2020 rover.
The Mars 2020 rover, the as-yet unnamed great-granddaughter of Sojourner, will be based on the design of Curiosity, but will be much more scientifically sophisticated. What's really exciting are plans for her to get the samples back to Earth, where they can be subject to much more sophisticated analysis. Hopefully, these will answer the next big questions. Is there still water on Mars today? And perhaps even life?
Our best bet for finding life is where there was water or where there is water. And so the first step in this process is to find the water. We know there was a lot of water on Mars, and there may be spots where there is still water close enough to the surface, but perhaps it's mostly underground.
And what we're doing with Mars 2020 is when we find rocks that look promising, we're going to drill a core, and we're going to stick the core in a tube and leave the tube on the surface of Mars for the future.
Those tubes could be the key to finding real Martians, if only microbial ones, and tell us how human astronauts in the future might be able to live on Martian soil, survive dust storms, and use Martian resources to create oxygen to breathe and water to drink. But how is that tube going to get back to Earth? That tricky question has yet to be fully answered.
In theory, a future mission will come pick it up and package it up into a can and basically get the can off the surface of Mars and bring it back to Earth. But all of that is on the drawing board.
For a mere $2 billion, the Mars 2020 rover will be our pioneer in realizing the ancient dream of Earthlings: to live and work on the Red Planet, our first stepping stone to new worlds and new possibilities. One thing is clear: Mars 2020 will have some big shoes, wheels, to fill. It will be quite the challenge to replace Sojourner, Spirit, Opportunity, and Curiosity in the hearts of the rover teams and their adoring public.
You know, they're very much like our human proxies on the surface of Mars, and they exhibit human-like qualities. I mean, you know, they're dutiful, they're intrepid, they're funny, and so we ascribe to them personalities and behaviors, and that only endears them more to us.